And really just finishing up this very last problem. We're going to get a parametric representation of this line segment. This is something that we did a long time ago, but you might notice that x would equal, well, an initial point. We could say that our beginning point is -5 comma -3. So we could certainly work that out. Now just look at your x change, delta x. Head minus tail is how we always found a direction vector. We're essentially doing that very same thing right now. That would be 5, so we could say plus 5t. Head minus tail for y. Delta y is 2 minus -3, and that's also a 5. So we could say plus 5t as well. While we're at it, let's go ahead and find x prime of t, because that very well could come in handy. X prime of t would equal 5 dt. And we can say y prime of t, well, that would be just a 5 dt as well. Technically it's a 5. I mean, we could have dy dt, but we can put that in there as well. As we work this line integral out, we're going to say we've got from cy squared dx plus x dy. And what we can do super quickly is say we know that our t value, when we've worked this out, and you can confirm this with your parametric equations for a line segment, wonderfully, we're just going to go between 0 and 1. Look, where we've got y squared, well, we said that y was -3 plus 5t. Our dx, well, you can see even at the top of the screen, it's x prime of t, which is 5, and then we'll put a dt in there. Plus, well, what about our x right here? X is -5 plus 5t. But what about dy? Well, dy is going to be y prime of t, which is 5. And then we'll have dt. So very nicely, what we can notice is that, well, I could pull a 5 out, and I have a dt for both of these differentials. Tell you what, we're trying to work this out very quickly in regards to time. But my goodness, once you factored out that 5, I hope you'd be able to finish this up incredibly fast. Look, -3 plus -5 is -8. 5t plus 5t is going to be a 10t. And from here, tell you what, just again for the sake of time, because we'd like to wrap up pretty quickly, if we were to just let the calculator help us out, we'll go down to integrate. Ironically, I think sometimes this is almost like slowing us down. I think we could have been done by now if we would have worked this out by hand. But there's our integrand. I brought the 5 back inside. This is with respect to t. And of course, we'll just go between 0 and 1. And very quickly, you can see that we get -15. So all of this is -15, a negative value. Well, that's for part A. How about for part B? They're saying, what if C is the arch of a parabola going from the same points? Now, if I gave you x is equal to 4 minus y squared, I hope you'd envision too, if I did x minus 4 equaled -y squared, you might think that x is equal to 4 and y would equal 0 very quickly. I hope you'd think that way. That would be your vertex of your parabola, and you're very quickly going to see that your parabola has the same endpoints as we did for the line segment, but it gets to the beginning and the ending of those points in a very different path. Now, that being said, and hopefully you saw off to the left-hand side how we graph those, I'd like to set up some parametrics once again. This time I'm going to let y equal t, and then x, very nicely, is 4 minus t squared. This is a nice little way to do your parametrization, because you can see that either x would equal t or y would equal t. Now, if x would equal t, you'd have a lot more difficulty solving for y. If y is equal to t, then we know that t is going to go between -3 and 2. Well, we could also quickly see that y prime would be 1 and x prime would be -2t. So just working this same integral out, of course you're going to see that our setup's quite a bit different. We're going to still have a calc AB type of an integral, but notice even the bounds are different right now. Y squared is going to become t squared. Dx is really x prime of t dt, and this is where we're going to get -2t dt. Plus, well, what did we have for x? Well, that's a little bit messier. It's 4 minus t squared. What about dy? Well, dy is delightful. It's going to be y prime of t, which is just 1, times the dt itself. Well, wow, look at that. Okay, so what we really have now is the following. Once we've made these substitutions, what we can do super quickly is just work this out by hand. Now look, we can have -2 t to the third plus 4 minus t squared dt. And again, we could get some help from the technology just to speed this whole process up, and hopefully it won't be so bad. Let's see, we could clear that out, press F3, integrate that, and it looks like we're going to be integrating -2 t to the third plus 4 minus t squared comma t, and we're going to go from -3 comma 2. And very quickly we can see we actually get a positive value. It looks like a 245 all over 6. So if we were to compare these two answers, we can immediately see, of course, that the endpoints really are not going to make a line integral have a definite answer. Both part A and part B had the same beginning and ending points, but the path that they went on, of course, was very different, and that path led to a very different line integral value. One was even negative, the other is positive. But again, the ongoing theme that we're seeing is it's very important to get the correct parametric equations and the boundaries. Hopefully this is going well for you. We're going to continue on with 2 more days of line integrals next week.